I am Dharani, working as an assistant professor in SNS College of Technology in Food Technology Department. I am going to explain about heat exchange. Heat exchangers are devices that facilitate the exchange of heat between two fluids that are at different temperatures without the fluids coming into contact. Heat is transferred from hot fluid to cold fluid. Heat exchangers are classified according to heat transfer process, type of construction, and flow arrangement as follows. Heat transfer process include direct contact heat exchanger, regenerative heat exchangers, recuperators, design and construction, shell and tube heat exchangers. If large are followed, a shell and tube heat exchanger is used, which is the most important type of exchanger in use in the process industries. In these exchangers, the flow are continuous. Many tubes in parallel are used where one fluid flows inside the tubes. Even though there are no strict conditions on these following points are taken into consideration, normally the corrosive fluid shall pass through the tube side as the replacement of tubes is easier and cheaper than shell side. The toxic hazardous fluid shall pass through the tube side because in case of any leakage it won't get exposed to atmosphere. Plate and frame heat exchangers. This exchanger consists of series of thin plates normal to the direction of flow of the fluids. Spiral heat exchanger. This exchanger is formed by spiraling two parallel flat sheets to form a spiral consisting of two flow channels. Double pipe heat exchanger. It consists of two concentric tubes with one fluid flowing in the inner tube and other fluid flowing in the annular space between the tube pipes. The fluid can be in co-current or counter-current flow. Cross flow heat exchanger. The fluids move in cross flow with one fluid flowing in the tubes and other fluid flowing over the tubes in the transverse direction. Find with both fluids unmixed, unfined with one fluid mixed and other fluid unmixed. Flow arrangements: parallel flow, counter current flow, cross flow. Parallel flow heat exchangers, where the fluid move in same direction as referred to as parallel flow. In parallel flow heat exchangers, the outlet temperature of the cold fluid can never exceed the outlet temperature of hot fluid. The exchanger is performing at its best when the outlet temperature are equal. Counterflow heat exchangers, where fluids move in the opposite direction, are referred as counterflow. Crossflow. In crossflow exchangers, the hot and cold fluids are perpendicular to each other. Heat exchanger analysis. Overall heat transfer coefficient LMTD. Effectiveness of heat exchangers. Overall heat transfer coefficient. Under steady operation, the mass flow rate of each fluid stream flowing through a heat exchanger remains constant. Log mean temperature difference. Log mean temperature difference is used to relate the total heat transfer rate to inlet and outlet fluid temperatures. It determines the temperature driving force for heat transfer in flow systems. The LMTD is logarithmic average of the temperature difference between the hot and cold streams at each end of the exchanger. The larger the LMTD, the more heat is transferred. The effectiveness NTU method. The heat exchanger effectiveness is defined in terms of actual heat transfer rate Q and the maximum heat transfer rate Q max would be obtained with heat exchanger of infinite area. Thank you.